Okay, thank you. Sorry. Okay, so I'm here as a representative of the National Atomic Energy Commission from Argentina. I will speak a little bit about the institution and then its involvement in the high energy cosmology and astroparticle project during his history. So, okay, here we are. So, the Atomic Energy Commission is organized as an autonomous body, and nowadays under the jurisdiction of the chief of the minister office. Previously was under the Secretary of Energy, but in any of the case, it was autonomous, meaning this that his budget was coming directly from the national budget that is discussed, approved, or modify every year in the parliament. The headquarters of the CNEA are in the city of Buenos Aires, but has present all over the country with different departments. The institution is mission oriented. It means that its principal activities are all related to the nuclear energy development since the very beginning of his history, more than 70 years ago. Actually, it was founded in 1950 exactly, so this year is exactly 74 years of history. And within the story of the institution, several atomic centers were built in the country. In particular, nowadays we have 3 operative atomic centers, 2 in the province of Buenos Aires and another one in the province of Rio Negro and in the Argentinian Patagonia. In these centers, the institution have built, is operating and maintain small reactors, medium reactor for doing research. Within the institution, linked to national universities, the Atomic Energy Commission has 3 academic institutes where degrees for physics, for engineers, for telecommunication are issued. There are also masters and doctorates programs in this institution. More or less, the whole institution has something like 3,000 employees between scientists and technicians, administrations. And to give you an idea of the budget, this is the number I put here, is the budget of this year that was in Argentinian pesos, roughly 100 billion Argentinian pesos, meaning at the present exchange rate, something like 100 and something million dollars. Of course, the bulk of this budget, as I told you before, is devoted to development all the nuclear activities. How the connection to the high energy physics, the cosmic ray physics, is actually started from the very beginning of the history of the institution. Already in 1954, 4 years after the creation of the commission, there were studies on cosmic radiation driven by the founding fathers of the institution. I think this is in the picture is rather in a mountain in close to Mendoza. They put in operation several observatories in the top of the Andes at several positions in Jujuy Andes in the northwest of Argentina, but they also put in operation laboratories in Buenos Aires, in Tierra del Fuego, and in Antarctica, and they started to do particle physics in these experiments. But it took almost 40 years until this seed really became a tree, because in the 90s, the Pierre Auger Observatory decided to host the observatory in the province of Mendoza in Argentina, and probably this was one of the milestones that changed completely the landscape for the high energy and astroparticle physics in the region. Nowadays, it's more than 20 years that the Pierre Auger Observatory is running, and gathering together 18 countries and more than 500 scientists from all over the world. And this November, in particular, will extend its lifetime for another 10 years. The Atomic Energy Commission was from the very beginning of the design of the observatory involved in the project. So, as I told you before, nevertheless, this fundamental physics, fundamental research is a small amount of the percentage of the work done in the Atomic Commission. I put here the first two levels of this organizational chart of the commission under the president. There is one department that is dedicated to non-nuclear project, non-nuclear activities, and research and development. And below this department, there are another two other departments that are involved in the topics that are the matter of this symposium. And just to give you an idea of how the CNEA how the part of the budget of the CNEA dedicated to this HECAP project, I put the number that for this year is roughly 1 billion Argentinian pesos, meaning something a number close to a little bit more than 1 million US dollars. These are completely allocated for the development of the project that I will tell you in a minute, where the Atomic Energy Commission is involved. In between all these departments I highlight here, there are more than 70 people sharing activities in between scientists doing research, this meaning engineers and physicists. There are technicians, and there are, of course, to make all this sustainable in time, we have students and doctorate students in particular. Okay, so what are the three main projects that we are supporting from the Commission nowadays? Are these three that are in this circle here. I already told you Auger in the province of Mendoza, in the center northwest part of Argentina, devoted to the study of ultra high energy cosmic rays. In the northwest, in the Salta province, we have Cubic, which is devoted to cosmology. and is nowadays putting in operation the prototype, the first telescope for the study the polarization of the CMB, and a little bit more far in the future is the Andes project, which is a multi-purpose underground laboratory that we would like to build with taking as an opportunity the tunnel that should be built between Argentina and Chile in the province of San Juan. Of course, if the tunnel doesn't happen, then Andes won't happen also. But if the tunnel is built, a small amount of the budget will be dedicated to the construction of the cave for this underground laboratory. These are ongoing projects, supported all of them in its different stage by the Atomic Energy Commission, and to all these projects, the budget I showed you before are the one that is allocated in the Commission. For the close by future, we are starting to investigate the possibility of having one of the grand prototype arrays, or its new proposal, which is Heron, which is a merge of Gran and Beacon, probably in the province also of San Juan, dedicated to the study of high energy neutrino with radio antennas. You probably will see, you have already seen the white paper that are presented or will be presented in the following days. So, of course, all of these activities have to be sustained in time, creating new qualified human resources or human capital, as you like. So after the success of the Pierre Observatory, the Atomic Energy Commission, together with one of the university which is linked to the University of National University of San Martin, created a program of double doctoral degree with Germany, with the Karlsruhe Institute of Technology, the KIT Institute in Germany. This happened in 2015, and it was very, very successful since then. I put here the numbers. We have already 18 graduates of the school, 9 by the side of Germany, and another 9 from the side of the University of San Martin. This means that the students that are participating in this program are not only or exclusively Argentinian and German. They are gathering together people from Brazil, from Italy, from Spain. So within the program, we have people from all over the world, India too. And so far, there are still 19 ongoing students with this separation between institutes, as you see here. The separation, that the only meaning here is that the institute, the mother institute, let's call it this way, has to the student has to spend 1 year in the partner institute and the rest of the PhD in the mother institute. So it's a small difference in the time spent between the two institutions, the difference of being KIT or UNSAM. And after this this successful program for physics, for astroparticle physics, 5 years later, and this is also a very important issue that have also always have to be in mind, that we need to produce also very high qualified engineers that are able to build the infrastructure at the edge of the technology for this kind of project. So in 2020, we created with the same institutions a double doctoral program in engineering and information technology. As is a newer program, we have only one graduate student so far, and there are 6 ongoing students doing this, participating in this program. As another important project that the Atomic Energy Commission is involved is a neutron beam laboratory that is being built in occasion of a new nuclear reactor for research that the Commission is close to finalize. It's already the 80% of the reactor is finished. This is a picture of the building where the reactor will be hosted in the province of Buenos Aires, in the atomic center, which is close by to the airport, Ezeiza. And close to this building, in this hangar you see here in the picture, there will be this neutron beam laboratory with different experiments and in different science. The 5 most important or foreseen experiments so far are the ones that are highlighted here in the bottom of the picture. You can see that 2 of them, the instrumentation for the 2 of them will be built by the Commission. So the science that can be done here is neutron diffraction, neutron imaging, and all the topics that you see here. Probably the most important take-home message regarding this new laboratory is that it will be the first one dedicated to the neutron science in Latin America. It will be large scale, and it's conceived as an open and user-oriented facility. And as this is becoming a reality, it's not completely closed. There is room also for other instrument or partnerships in the region. Something that is very important also to stress is how all this the project that are international collaboration, as the one I showed you before in HECAP, where we are involved, need financial engineering behind. Something of this was mentioned this morning, where the AWECNA Foundation and the previously foundation, the FOPA, the Fundación Observatorio Pierre Auger, were putting in place to manage the money flow between the different agencies. This is something that probably we need to bear in mind if we want to really create regional collaboration and fostering the regional and international large research infrastructure. AWECNA so far is behind the management of the money for Cubic, for Auger, and for Andes. Even Andes is a small part of it because it's far away in the future. But for example, since 2015, I put here the number, that this foundation managed for OGE, which implies also the upgrade of OGE Prime that cost more or less $16 million. And also is in charge of managing the importation that is required for building this kind of infrastructure. So with this, I would like to conclude. I briefly make an overview of the contribution of the Atomic Energy Commission to the project of high energy and cosmology or astroparticles in the region, and we can say that all these projects I mentioned are within the strategic plan of the institution for the following years, and the CNEA was involved since the beginning of the Pierre Auger Observatory and never stopped this supporting the development and the maintenance and operation of this kind of infrastructure, and is willing to do the same for other projects like cubic Andes that are in the future. It was also part in CTA, in Swigo, and in Huron and Grande would like also to participate. I have to say here that, of course, the amount of participation of the Commission will depend, and depend also with where these observatories are hosted. It's not easy for the Commission to make a strong support in money, I will say, for observatories that are in other countries. This is something probably we should think of for the future. And what is certainly true is that the Atomic Energy Commission is fully committed in the continuous strengthening of this kind of project and the human resources that can be formed within them. Thank you.
Thank you. Questions?
So Federico, thanks for the talk. I have a couple of questions. One is about the role of CONACYT in Argentina.
Okay. Okay, CONICET, you mean CONICET in Argentina is a completely different institution. It's another autonomous institution, which I'm not representing here, so I cannot formally say too much in this regards. But just to make you an idea, the two are two autonomous body for science and technology. This is, and the two receive budget from different channels from the national budget, which is discussed every year. From the point of view of how they develop science, I think the main difference is that the Atomic Energy Commission is completely mission oriented. So one, it starts in a project. It has the capability of building, designing, and operate this kind of project because of the experience gained over 70 years building atomic reactors. So has a huge capacity for building and operate stuff, let's say. And the CONICET is more widely institution for scientific development, covering many other aspects of science.
Okay. Thank you. And so another question, sorry, just to complement. So two quick questions. One is this from the Fundación Atómica that you mentioned. I remember at some point CLAF had also some role in financing Andes and in the sense of financial engineering, no, of being able to be used, no, as an institution. Now, is this still going on or not anymore?
Well, actually, I don't know how was the engineering for Andes in CLAF. Is right now what I showed before is that is the CNEA related budget that is managed by AWECNA. So as I told you before, once the Atomic Energy Commission decide that support a project, Andes is a supporting project, dedicate as part of its budget to it, to develop it. And this part of the budget is managed by AWECNA. The other channels of financing Andes, as the one you are mentioning, I really don't have information.
Thank you, Federico.
Hi, Federico. It's Ulysses here. Do you hear me?
Yeah.
Federico, my question is a bit speculative. I'd like to know your opinions or ideas about it. I mean, you mentioned a large experience of CNEA with the history of Cogen in Argentina, and you've listed a number of experiments there that are little by little building a lot of critical mass in the continent in the field of astroparticle physics. So I understand that it's always easier, and we have discussed that many times, and it's natural to support and to invest in experiments that are within the country. But the fact that we are amassing such a critical mass in the continent makes me almost convinced, sure, that we are at the verge of having enough momentum in various places to try to pull some regional alliance at an institutional level to start doing something that go cross borders, maybe through local initiatives that are networked, maybe through something that is more institutionalized at the regional level. But I really think that if there is a field that is starting to be in that position and to really integrate the region in a very concrete way, that would be astroparticle physics. Also because the technology, the possibilities for involvement in technology by the various countries of the continent are various. The level of human training that you can do is very interesting and transferable. That means data science, AI, electronics, photosensors, things that have an impact in industry. And we have already a lot of people that could start something like this. So I would like to hear from you a little bit. I mean, how do you see that? And I'm asking this question to you, not to others, because I think Argentina, because of its pool of human resources in the field, and particularly the experience of Cogen, is perhaps in the prime position to think about this. So could you comment on this?
Well, yes. So let me. I will tell you my first of all. As I told you during the presentation, I agree with you that the success of the Auger Observatory completely changed the landscape for our field, demonstrating that big science can be done not going towards the center of the knowledge production, let's say, or the technology, but bringing the technology here. And I think we have a window of opportunity in this field, in the astroparticle and cosmology and astronomy, to push forward the development of large infrastructure here, but not only importing also the technology. This was the reason of my question this morning. Trying to foster the development of technology here also in the region. I think Brazil has a very integrated matrix of industry and production. Argentina has not so big, but it's important. Chile probably the same. So I think we need to take this opportunity to build large infrastructure here in the region and start producing technology in the region. And this will convince our policymakers to invest the money in this kind of project. Something that I felt that we are missing, and probably this is the reason of your question, is we need some more integration between the countries. There is not an entity that allows us to think in over the borders of our country. The institution, as we have it now, are somehow linked to the past and not making this kind of integration. And we need to make this. I think we need to build this. So it's finding among the institutions that we have what could serve as a interborder institution also for the development of all this kind of infrastructure. And we already have OGE. We will have SWIGO in the future. As I told you, we are aiming to find a site for SWIGO, for grant, or its combination with other radio antennas in the world. So we will have cosmic ray, the largest cosmic ray observatory in the region. We will have the largest gamma ray observatory in the region. We could have the largest high energy neutrino observatory in the region. This is a huge opportunity that we need to really think how to make it work in a regional vision.
We need to move on. Thank you, Federico. Speaker is also there. Enrico.
Hey, hello. Yeah, I'm here.
So, you can share the screen.
Let me check if I can share my screen. I believe so.
Right. So our next speaker is Enrique Pazos from the Secretaría Nacional de Ciencia y Tecnología de Guatemala. Please.
Thank you. Thank you very much. It is a real pleasure and honor to be here in this meeting. I would like to talk to you about some highlights in the public scientific funding in Guatemala and how it is related to the physics effort that we are all interested in here. Well, first of all, just to set some context, this is a schematic of how our national science and technology system is built. So we have the CONCYT, which is the Council, Consejo Nacional, which is the highest level organization that rules all the matters of science and technology in Guatemala. This council is it's formed by 9 members, and it has representation from government, from academia, and from the industry in Guatemala. Then we have SENACYT, which is the Secretariat, Secretaría Nacional, which is the institution which I am representing today. And we execute all the policies that are thought and originated in the council. So here we have a large amount of people doing all this work, and we administrate the National Fund of Science and Technology, of which I am going to mention some details later on. As the institution, our strategy, starting off right now, and this is also to set some context. We have recently a change in government here in Guatemala, starting this year, and we have a very good support for scientific activities. This institution, CONCYT, which I represent today, is directly below the vice president. And right now we have a female vice president, which actually she's a scientist, she's a biochemist. And we have a really, really strong support to implement and follow up all sorts of scientific initiatives. Well, I myself, I am a physicist. I was, until a few months ago, I was a professor at the public university. And well, starting in May this year, along with other colleagues, also from the scientific field, we are trying to implement in the Secretariat all these ideas. So first, we need to secure political and sectorial articulation, I mean, in between industry and different actors in our country, which is something that it has been very, very weak. We are also very aware that we need high-level human talent training. And by this, we mean actually graduate students. Because here in Guatemala, graduate programs in sciences are very scarce. There is pretty nowhere to study a master or a PhD in basic sciences. We do have right now a master's and a doctorate degree in physics, but they are very, very recent. We also seek international cooperation and articulation, and this opportunity of being here is actually really important for us. We also are aware that we need to strengthen our local institutions with more people from the scientific field, because it has been a tradition here in Guatemala that scientific institutions are being administered by administrative people, not from people from that are actually scientists. And we are focused in dissemination of science, technology, innovation with a territorial focus in Guatemala. And of course, the inclusion of women, indigenous people in science, technology, and innovation. Some of the topics that we are interested as a country are combating poverty and hunger, health, well-being, quality education, climate and climate change, sustainability of cities and communities, orange economy, and of course, these are of national interest, but all of these are supported by basic sciences, which they do not show up like in the main focus, but we know that without basic sciences, all these things they don't have really good support. And here, just to mention the legal frame in which all the scientific effort operates here in Guatemala. We have in the Constitution, we have Article 80, which mentions explicitly the importance of science and technology. And we also have a law, the Scientific Promotion of Science, which is very recent. It is from 1991. As you can see, it's, I don't know, a few years ago. I was still in high school by that time. So I guess compared to other countries, this is very recent. And therefore, we haven't had a long path trying to implement many of these ideas. And probably the other interesting thing for us here is along with this legislation, there was also the creation of the National Fund for Science and Technology, which I would like to talk a little bit now. So this National Fund, which is a trust or a fideicomiso in Spanish, it's built in the following way. We have the operating expenses. This is about I'm gonna put quantities in US dollars, $2.8 million per year. So this is the payroll and water, electricity, and all that kind of things that we need to actually function. But the National Science and Technology Fund is $1.6 million US dollars per year, which you may say is really, really small, and it is. And this is not just for physics, this is for everything that we got. And the total, the budget of our institution is about $4.4 million per year. This has some fluctuations, sometimes it's a bit more, sometimes it's a bit less, but it is around that. So this is what the government of Guatemala invests in science and technology. And if you are familiar with the statistics, is one of the smallest budgets in all Latin America, to not say in the whole world. With this kind of money, we have basically 4 programs which fund different scientific activities. We have one for high-level human talent training, which is pretty much, we would like to be graduate students, but it is not. It is also undergraduate students. We have another program for research based on social and productive demands. And here is where all the scientific research pretty much goes. And we have some part for innovation and technology transfer, and some other part for science and technology popularization, which here we mean workshops, conferences, and any kind of activity that has some outreach to the people. And just to mention a little bit of the situation of physics in Guatemala, these are the universities which have some program in physics. We have the Universidad de San Carlos, which is the public university. We have here the undergraduate program, which started around 1980. We have a master's in physics, which started around 2003. And recently a PhD, which started in 2021. So it is really, really recent. Here, the numbers are not very high. We have right now 4 students in the doctorate program, about 8 in the master, and I would say about 100, more or less. My colleagues in Guatemala can correct me on that. We also have the undergraduate degree in physics in 2 other universities, Universidad del Valle, which started in the 70s, and more recently, Universidad Mariano Galvez, which started its undergraduate program in 2015. I would say the largest project in collaboration that we have is LAGO, which I'm sure you all know, between University of San Carlos and Del Valle, which has been a collaboration that it's been a little bit slow, lack of funding. And right now, this because we have spoken recently with Fernando Quevedo to create an agreement with CERN, which is currently under development. So just to finish up this presentation, one of the problems we really have with funding high-level education is that we lack scholarships. So our students in the master's and doctorate degrees are really people that need to work to support their students, their studies and to support their living cost. So this has the obvious drawbacks that I don't have to mention. And we are trying here at the Secretariat to try to implement real funding to at least have real scholarships to support master's and PhD degrees. So I will leave it here because of the time. And if some of my colleagues in Guatemala would like to add something, but they are very welcome. And I thank the opportunity to join this meeting, and anything that we could implement is going to be really, really welcome. Thank you very much.
Thank you. The audience, is there any question?
I guess regarding the collaboration agreement with CERN, do you have any specific experiments in mind as a country yet, or is it a general one?
It is a general one. We are mainly interested in the exchange of students and professors so that students can go probably for summer school or some conference. We would like collaboration probably with master students. We are not, we don't have big numbers there, but mainly we are interested in this kind of exchange as a first step to foster this knowledge and collaboration between Guatemala and CERN.
Now, in the university, you have this doctorate program.
Yes.
Is generic for all areas, or are there many? Do you have some numbers to give us?
Sure. We started in 2021 with 4 students, which they are still working their thesis. And yeah, because there are very few, I can mention them all. 2 of them are actually working in medical physics, and 2 of them are working on environmental physics. So it's not an area in particular. We left it open because as you can imagine, we cannot afford focusing in just one particular area. So it is pretty much open to whatever the students would like to develop. And that could be astrophysics, particle physics, whatever area of interest.
Thanks. Any other question? No? Let's thank Enrique.
Thank you.
Yeah.
So I need some help here with the technology.
Our next speaker is Martijn Mulders.
Okay, can you hear me outside if I speak like this?
People online, can you hear Martin?
Yes.
Yeah,
Okay.
loud and clear. Yeah.
Okay, thank you. And thanks to the organizers for hosting this symposium here. It's has been very nice already. So and thank you for inviting me to speak. So I'm going to talk about the Latin American participation in the CERN program. I don't know how much new I will tell you because it has been mentioned already quite a few times today. But let's see. So first I wanted to say a few words about myself, why I'm here and who am I. So my main reason to be here, of course, is that I'm member of the preparatory group of LASF4RI and also of the Latin board member of the Latin American Association, which came out of the first LASF4RI iteration. Then I'm also director of CERN Schools of High Energy Physics. So we organize schools in Europe, Asia, and also Latin America. And so the last 3 schools were in Mexico, Argentina, Chile, and the next school will be in 25 in Costa Rica. So those are my connections to Latin America. And but my main job at CERN is I'm just a research physicist. I know nothing about funding, so in that sense I'm maybe not too useful today. But I am in the CMS experiment, and previously I worked in D0 and Delphi. And it turns out that those are also experiments that Latin America has been involved in the past. And my topics of interest are listed there. So I like precision measurements, but I also have worked on diffractive physics with detect protons and muon identification and reconstruction, including cosmic muons. And those are also topics where I have collaborated with people from Latin America before. So it's a little bit of a coincidence there, I think, the connection. But so that's why I'm here. I thought before specifically talking about CERN, it would be interesting to look at the history of involvement of Latin America in high energy physics by looking at some of the milestones in the field. And yeah, as was mentioned already earlier today, here in Brazil and elsewhere, you are celebrating 100 years of César Lattes. Of course, it's famous for the discovery of the pion. And this was with cosmic rays. And already soon after, they started to do studies of particles in the laboratory with handmade collisions. And of course, in high energy physics, you need to go to higher and higher energies to study smaller and smaller distances and really get to the fundamental particles of nature. And the higher energy you need, the larger the collider becomes. So if you want to do this in controlled conditions in a laboratory, you need a bigger and bigger laboratory to reach higher and higher energies. And so here I listed for increasing energies, basically different discoveries. So first of all, if you look at 1983 at CERN, the discovery of the W and Z bosons. If you look at the discovery papers, there were no Latin American institutes there. And I'm not talking about individual contributions here. It's my disclaimer. So it's purely looking at the institutes. Then if you look 10 years later at FERMILAB, needed to go to higher energy to discover the top quark. And if you look there at the discovery papers, there are actually 3 so Latin American institutes listed from 3 different countries, and they all found their way to D0. So the collaboration with FERMILAB was going strong on that. Well, roughly at the same time, at CERN you had the E+ E- collider lab and SLD in California doing very precise measurements of the Z boson in particular. And if you then look at the final paper in 2005, there are 4 Latin American institutes, in this case all in Delphi from Brazil. Okay, then 20 years later is the discovery of the Higgs boson. And there you see in ATLAS and CMS already a much stronger involvement from 17 institutes, 5 different countries. And this is only counting ATLAS and CMS. There are also other LHC experiments. So if you look today at all the CERN experiments, there are about 40 institutes from 9 Latin American countries. Okay, so this is just an illustration, a little bit of the increasing involvement of Latin America in high-energy physics. And if you look in more detail at the users of CERN, you can see they are from all over the world. And I want to point out here that the definition of CERN user is rather specific in these statistics. So in a time window of 5 years, you have to spend 5 years actually at CERN. So you have to have the possibility to travel there. And it means that typically the local communities in the countries of origin are a factor 3 to 5 larger than the numbers that are coded here. So the different colors are in dark blue, the member states, mostly in Europe. Then an increasing number of associate member states. And as you have heard already today, Brazil is now one of the associate member states. And that's, so yeah, that's why Brazil has a different color. And what did I want to say? So yeah, so I color-coded here the countries from Latin America. So indeed, Brazil is the first country in the Americas to become an associate member state. Yeah, so here you can see an evolution as a function of time of the number of CERN users. On the left-hand side, it's a breakdown in all users, member states, observer states, and non-member states. So you can see that it increases to about 14,000 before COVID, and then there's a dip because people couldn't travel, and this definition of users that you go down. But it's good to see that now after COVID, it's going up again. And then if you look on the right-hand side, there's a breakdown for the different regions. And I used the logarithmic scale here. So you can clearly see Latin America here. So it's relatively small compared to other regions, but there's this very strong increase from 2005 to 2015. And as mentioned before, I think the Helen and ePlanet mobility program was really useful to enable this increase. And yeah, then after this, there's a small dip and then the COVID dip, but again, we are going up again. So this is a map of the current participation. Now, not only looking at users, but also at institutes for each of the countries. So as mentioned, Brazil is now an associate member state, and Chile has made an application to become an associate member state, and they are, I hear they are really making good progress. So that could happen soon. And yeah, so normally there are like different steps. So as mentioned just now in the previous talk, actually, one of the first steps typically is to have an international cooperation agreement. And CERN has this with 11 countries. And Guatemala and Uruguay are under discussion, but the other countries are all listed there. And then I will come back to this in the next slide. But in total, there are about 300 users from 40 institutes in 9 countries, which is a fraction of about 2.5% of the users in CERN experiments. And CERN experiments, it's not only the LHC experiments, but there are several other ones as well. So there's ISOL, there's RD51, NA42, NA62, etc. Then there are additional users who have Latin American nationality, but have gone to different countries. And there are also possibilities to collaborate, not with a physics experiment, but for example, with the accelerator sector. So you can see there, Argentina, Brazil, Colombia, and Mexico have collaboration in that sector. Okay. So to explain a bit, because there were some questions earlier today about this as well. There's different forms in which you can collaborate with CERN. Roughly, there are 3 types. So 3 columns here. So one is to have so-called institutional participation, which is between CERN and the national level. And so there, to be a member state, you really own part of CERN, and you contribute to the CERN budget. And this is the amount is proportional to your GDP. So it's in that sense, it's fair. And this gives you access to industrial contracts and jobs at CERN. Then an associate member state, you get a discount of up to 90%. And you basically get the same rights, but there's a ceiling then on the amount of return you can get. But yeah, so Brazil is already there, and Chile will hopefully be there soon. And then the third way is this international collaboration agreement. Yeah, so that is more an expression of interest, as mentioned, to allow exchange of professors and students and scientific collaboration. But yeah, so that's the left column. Then the middle column is more at an individual level. So there are quite a few programs. There's the summer student program. So that's an internship at CERN for 2 or 3 months for students. And this is also about half of them are from non-member states. So it's very accessible in that sense, although funding has to come from somewhere. So that's not automatic. And then, as mentioned, the CERN schools, they are organized inside the region here. Yeah, so I will get back to that. So also there, non-member state students are welcome, and they are supported. So they are supported by CERN and other sponsors. Then there's technical and doctoral students. Those are 2 or 3 year positions at CERN. And normally they are only for member states. But if there's funding, non-member state students can also benefit from this arrangement. And teacher programs, again, if you are a member state or associate member state, there should be a program in your language for your country to teach high school teachers about high energy physics. And I think it's typically a 1-week stay at CERN, and it's very popular. If you are not an associate member state or a member state, then you can join sometimes general sessions but it's only in English and Spanish. Sorry.
In Portuguese, no?
Not. Yeah, now you will have it. I think there was an arrangement with Portugal that helped with that. Yeah. Okay, then of course, if you want to really engage at scientific level or technical level, we're talking about the collaboration between your institute or laboratory with an experimental collaboration. This then gives you access, to the whole ecosystem of the collaboration, a network of hundreds or thousands of physicists, possibly around the world, and you can have different kinds of membership, either technical or full collaboration membership. The terms and conditions are different from collaboration to collaboration, of course, but this is generally true. And if you are a full collaboration member, then you share in everything, all the parts of doing the research, but you also have to help with the work. So provide part of the hardware, write software, help with operations of the detector, and then you can do your analysis and publish your research. And in this case, you typically have an MOU, Memorandum of Understanding, that defines in more detail what the conditions are. But so today there was a question, now that Brazil is associate member state, does that change the costs for the MNO, for the collaborations? But the answer is, well, it's basically no, it's something separate. I just wanted to give one example of capacity building. And of course, it's the one that is closest to my heart. It's the Latin American Schools of High-Energy Physics. So we host this every 2 years in a different country. And it started in 2001, and we have been twice to Brazil, Mexico, Argentina, and Chile, and one time to Colombia, Peru, and Ecuador. Yeah, so some of you may recognize this picture from the school in Ecuador. Rogerio was there.
I was a student.
You were a student there?
From 2012.
20.
It was I believe was the first school in Brazil.
Oh, that was the second school in Brazil then, yeah.
In Natal.
Yeah. Edgar was also here.
Yes.
So these schools are 2 weeks. They are residential in the place. So it's targeted for higher level students, ideally PhD or advanced master students. And yeah.
I was privileged. They invited me 3 times, so I don't know why.
But you had to work.
It's a lot of work. It's a lot of fun too.
Yeah. So and the point here is that CERN and also CIMAT from Spain, they provide sponsorship, and sometimes there's additional sponsorship from countries in the region, which means that students from Latin America are fully or can be fully sponsored if needed, both the travel and the participation in school. And of course, it's not only about the scientific training, but also about meeting teachers and other students from different countries from the region and elsewhere. So yeah, so that's a great program. Then how am I doing on time? Not great, I think. So, I just wanted to mention CERN also has other contributions, let's say, to the community. One thing was already mentioned earlier today: open science, open access. So there's this co-op partnership that is hosted at CERN with contributions from all over the world, and then Chile recently joined this co-op consortium. So they ensure that you can publish open access at no cost to the authors, and I think 90% of particle physics publications are happening in this format now for experimental papers. CERN is also hosting Inspire. Now originally it was Spires, so Slack and Daisy, but CERN is now taking care of that. And CERN is also very much supporting open data. So there's this open data policy encouraging the LHC experiments to make the data available. And I saw in some of the white papers that this is useful for training purposes, also here in the region. So yeah, please keep that in mind. I will go quick on this because you know this much better than I do. We are aware there are challenges in participation. So there's the challenge of training students and offering positions, which is all necessary to have a full talent pipeline. And then you have the brain drain. It was already mentioned that about 40% of the CERN users with Latin American nationality actually work elsewhere. And then, of course, there's the funding, already mentioned many times today, and also the travel. And yeah, so I'm sure this will be discussed more this week. So then I wanted to briefly say a few things about what is actually happening at CERN in terms of research. So it's a very broad scientific program, from nuclear physics to antimatter, cosmic rays, fixed target experiments, and also an important contribution to June through the neutrino platform. And of course, there's the flagship project, the Large Hadron Collider. And I stole this slide from the previous symposium, where you see the 4 experiments and the countries that are involved in each of these collaborations. And in orange, the countries that have been added since the last time. So there's Costa Rica, who joined LHCb officially. Honduras is interested and in the process of joining LHCb. And CMS has been joined by Chile. And Peru is also interested with an institute to join CMS. And this is called flagship for a reason. So it's not only very big, but it's also you know, a 30-year time span of operations. And in the number of years, we are now halfway. So yeah, 2024. And so the first phase is almost finished, and it's on track to deliver 300 inverse femtobarn. But the idea is that then in the next shutdown, the LHC is upgraded to higher luminosity. So in the second half, we hope to have 10 times more data. So there's still a lot of physics to come. And already with the current, so less than 10% of the full data set, we have thousands of publications. So all the experiments combined, almost 4,000 publications. And the experiments are already now operating way beyond the design limits. And there's all kinds of smart and innovative strategies being adopted to go even further. And so we're talking about using GPUs in trigger and offline, and trying out different data flows and data formats to push even further and extract more data and explore lower thresholds and have a better physics reach. But there's a limit to this. So for the high luminosity LHC, when the conditions get even tougher, the experiments need to be upgraded. So all of the LHC experiments have ambitious upgrade programs. And for the first shutdown, those upgrades are already in the process of production, and soon, well, soon we'll have the shutdown, and it will have to be installed and commissioned. And then LHCb and Alice are also eyeing on the next shutdown with even more innovative upgrades, where there are maybe very interesting opportunities also for countries who want to join. And I just wanted to show quickly 2 examples of upgrade projects where Latin America has played an important role. So there's the new small wheel for Atlas, where Chile played a very important role in building some of the muon chambers. And on the right-hand side, you see a contribution that was made here in Sao Paulo, if I'm not mistaken. Sampa Essex chip for the, okay, well done, for the LSTPC. And if I understand correctly, both of those are now installed and working well. Yeah. So those are great and very visible contributions. All right, so what is next for CERN? So right now we are following the 2020 European strategy priorities. Well, I already mentioned the full exploitation of the LHC, a diverse program of other experiments. Then, but you will hear more about that tomorrow, as we are thinking about the next major project for CERN, and one of the tasks was to do a feasibility study for the future circular collider. And they did an amazing job studying in detail all aspects from financial to civil engineering to the physics case. So I hope Christoph will tell you more about that tomorrow. Then, of course, there's all these new developments in accelerator research, detector research for the future, and et cetera, et cetera. And then, as mentioned, there's the neutrino platform. So yeah, so there's an important contribution there, both having a test set up at CERN of parts of the Dune detector and an in-kind contribution to the actual detector. Okay, so then, as you will hear from Paris, Svikas, also tomorrow, I think. Tomorrow, yes. The next European strategy has been anticipated, and here you see the timeline. So by mid-2026, we hope to have the results of the next strategy. So that's all I wanted to tell you. So I didn't go in much detail, but CERN has a very exciting scientific and technological program. And we welcome contributions from all over the world, and especially also from Latin America. And so we are happy not only for new countries to join, but also for the existing ones to further increase responsibilities and getting more and more involved. And we are also very supportive of the process here to increase dialogue and further enhance cooperation in the region and with CERN. So yeah, that's all I have.
Thank you.
First of all, the summer schools you are obviously very involved in.
Yeah.
The funding, is it 100% CERN or is it with the hosting country?
It depends a little bit on how much the hosting country can provide.
Oh.
But CERN has a fixed budget for that. So typically it's mostly CERN. I think I mentioned CIMAT, so the laboratory in Madrid, Spain. They have always supported the school also. And from time to time, we have had sponsorship, for example, from Brazil, from CBPF, or and sometimes from the local host country.
Yeah, I mean, I would like to ask for advice. Suppose I want to go to my funding, Latin America funding agency, and get some money to contribute to some instrumentation. So what should I tell the funding agency that will convince that it's good for Latin America to suppose? I mean, for instance, in this case, you have a public data policy. So the funding agency could say, okay, but you don't need to take part in instrumentation to get free access to the data. So why do you really want me to give you money to be part of to contribute to instrumentation? What would you answer?
Well, I think it really depends on what kind of technology you would like to provide. So, okay. So this is not my daily job. I'm not normally doing this sales talk. So I think some of you have more experience with how to approach that. But so clearly, clearly there are potentially interesting beyond the state-of-the-art technology challenges in some of the experiment upgrades. So I think it's typically a dialogue between you and representatives of the collaborations to identify to see if there is some kind of technology or service that you could contribute that is useful for the collaboration, but also useful for the country, as you said, to support, to further develop this industry in the country. But it really depends on the situation.
Yeah.
Yeah.
So first of course you need to contribute to the experiment. So usually you can just go there and say on the data analysis. So the experiment expected to contribute somehow. And to convince your local companies, usually you come from technology side and you try to involve the local industry. That's really a key issue now. If you say, I want to contribute to my experiment, but I want to build it here and take it there, and it helps a lot. That's the key aspect. Yeah.
Yeah. About the open data, that is something, and you don't get immediate access to all of the open data. And it's, I don't have experience myself in using open data. Again, I think some of you have more experience with that.
Yeah, so there's an embargo period that we apply, I guess that is common throughout the different LHC experiments at least, but I don't remember exactly, but it's at least 6 years or 10 years, depending. So if the scientists are still using those data, that data is still in embargo. So we only release after we have actually consume all the possible ideas or interest within the collaboration. Yeah, so that's there's a timeline to follow. And regarding the question, so I'm kind of in the middle of the same process in my country, and what I usually tell them is, well, what they usually say is, okay, what do we get from CERN? So what I'm trying to do right now is to convince them that we shouldn't ask that question. We should say something like, how can I contribute to the knowledge, to the worldwide knowledge? How can Latin America, for instance, increase? Because I think in this previous meeting that we had, someone from UNESCO said that Latin America only contributes 3% of the total scientific knowledge in the world or something like that. And I felt kind of ashamed. That's what I usually tell these people at the funding agencies, that we don't contribute more because our population is quite large together. And so in doing so, you get some benefits as a side thing. For instance, we can increase our capacity in engineering and things like that. But it's always difficult to sell anything.
In the kind of gaining visibility.
That's right.
Sometimes there are also creative solutions in the sense that you don't have to contribute technology, but you can maybe send engineers to work at CERN and be trained. But that could also be an in-kind contribution that works both ways.
Maybe there is a synergy with the strategic direction. For example, today you heard that CNPQ has some strategic, strategic plans, issues that so maybe artificial intelligence be something where to fall into the proposal. Yeah.
And there is there's a question from Zoom. Sharapira.
Hello. Yeah, thank you very much for the presentation. Very informative. I have some technical questions. When you talk about scientific collaboration in that slide, do you mean cluster cooperation? Is it cluster one? And
sorry, it is hard to understand. There's an echo.
Yes, sorry. When you talk about scientific collaboration,
Yes.
does it mean it is a cluster cooperation? Because that's once, for example, this summer school, and another question is related to summer school program and the schools in Latin America region. Also, computer school. I know that this year SAIFR, our institute, got the opportunity to organize a CERN computing school also. So those, where can we see the applications? It's on CERN's website, or can we promote it inside our country? And being a part of scope agreement, Chile, what benefits do we get, additional benefits compared with other that are non-scope signatories? Thank you. I got a little bit confused, so I need just clarification. Thank you.
Okay, so I think I heard 3 questions. So one is about scientific collaboration on this slide. Here I did not mean collaboration in the form of a cluster of institutes joining CERN or anything like that. I meant scientific collaboration between an entity, like one institute or a consortium of institutes, let's say in Latin America, with a existing collaboration at CERN.
Does it have to be within MOU agreement?
Typically, that comes with an MOU agreement. Yeah.
Okay.
And then the second question was about accelerators, schools, and so the CERN. There are 3 types of CERN schools. One is the high energy physics school. That's the one I am involved in. CERN also organizes the CERN accelerator schools and the CERN computing schools. Normally, they are only happening in CERN member states. I don't know. So, and I don't think they have been to Latin America yet, but that could change. Now that Brazil and hopefully soon Chile become associate member states.
It was announced for us that we will be hosting computing school in 2026, if I'm not wrong.
Ah, very good. Yeah.
Yes.
So, I mean, we have, yes, you can advertise that, and we have websites at CERN announcing these schools, but we also have, we normally advertise to like 200 universities all over the world, and we always, yeah, so I think the community will be very well aware of this. Then about SCOAP, the open access. To be honest, I'm actually not sure if Chilean authors have special benefits now that Chile contributes to this global partnership. I don't know if anyone else knows that. I can find out and get back to you. Did I kind of answer you?
Yeah, kind of. Thank you.
Okay, thanks, Martin. Next speaker is Lia Merminga from FERMILAB.
Stop sharing.
Right, she's yeah, you need to stop sharing. Thanks.
Thank you. Hello, everyone. Can you hear me?
Yes.
Okay, very good. Thank you so much. I'm very happy also to say that my colleague Marcela Carena has joined me as well. So if you have any questions, both of us are going to try to answer. So thank you so much for the kind invitation to speak about our strategic plan and with emphasis on the Latin American collaborations. Okay, so starting from the top, FERMILAB is the United States Particle Physics and Accelerator Laboratory. We operate the largest accelerator complex in the US, second largest in the world after CERN. We have about 2,100 employees, and we're sitting in a beautiful 6,800 acres of federal land. Our facilities are being used by users from around the world, from over 50 countries, and that includes accelerator facilities and detectors and computing. And as we move into the next 50 years, our mission remains to solve the mysteries of matter, energy, space, and time for also the benefit of all. In our 55 years of discovery of illustrious history, we have discovered the top and bottom quarks and the tau neutrino and participated in the discovery of the Higgs boson at CERN in 2012. And our history of discoveries is intertwined with the entire Americas and Latin America in particular, when in the 80s already, the second director of our laboratory and Nobel laureate Leon Lederman invited Latin American physicists to join FERMILAB experiments. And in the 1990s, this led to leadership roles in the discovery of the top quark at the FERMILAB Tevatron. And you can see here in the picture on the right, the president of Brazil, together with the Deputy Secretary of Energy visiting FERMILAB in 1989, when John Peoples was the director. Our program today is really to enable the strategic plan that's written in the P5 report. As you know, the P5 report is the US strategic plan for high energy physics for the US, but in the global context, and it spans a decade, but also looks into another decade down the road. The most recent P5 report was published in 2023. You'll hear tomorrow from Hitoshi, the chair, one of the co-chairs of the P5 panel, and it identified 6 science drivers, starting from the very small, elucidating the mysteries of neutrinos and revealing the properties of the Higgs boson, all the way to the very big, determining the nature of dark matter and what drives cosmic evolution, and in the intermediate scales, search for direct evidence of new particles and quantum imprints of new phenomena. So based on this new P5 report, as well as the 2014 P5 report, we have outlined, delineated our science and technology strategy for FERMILAB to support these P5 strategies. And our strategy encompasses 5 major particle physics initiatives on neutrinos, Higgs and the energy frontier, muons, the dark universe, and accelerator science and technology. 3 emerging technology initiatives, quantum, QIS, microelectronics, and artificial intelligence, and 1 user and stakeholder engagement initiative that we call Discovery on the Prairie. So in this talk, I'm going to present and give you a brief overview. It has to be very, very brief to fit in the 20 minutes. Brief overview of all our 9 initiatives, and then I will interleave there our collaborations with Latin American countries as best I can. And I want to apologize up front. I'm not going to be entirely comprehensive due to the lack of time, but I'll do my very best. And I also want to thank my colleagues for providing a lot of information to me for this talk. So our highest priority program at FERMILAB is the program of neutrinos, the science of neutrinos. And delivering the LBNF and DUNE experiment is our highest priority. Endeavor, absolutely. And DUNE is being built to be the definitive neutrino oscillation experiment, as the P5 report called it, and it is driven by LBNF, the Long Baseline Neutrino Facility, and PIP2, a state-of-the-art particle accelerator. PIP2 is a new superconducting radiofrequency accelerator that we're building currently at FERMILAB, and LBNF is the dual-site detector long baseline facility with detectors here on site at FERMILAB and detectors 1 mile underground in South Dakota. PIP2 accelerates up to 1.2 megawatts of proton beam power, which hit the target, produce the most intense beam of neutrinos, which then traverse the mantle of the Earth for 1,300 kilometers and arrive 1 mile underground in an old gold mine in South Dakota, where we have detectors filled with liquid argon, the state-of-the-art technology for neutrino detection, where the interactions take place between neutrinos and liquid argon, and where that then leads to science. This is a major investment. I should also say LBNF and DUNE is the first internationally conceived, constructed, and operated mega science experiment that the US, the Department of Energy, is executing on US soil, whereas CERN has been doing traditionally many international projects. US has not really, and this is the first one on US soil. So it represents a multi-billion-dollar investment by the Department of Energy, the US Department of Energy, as well as international partners. And why is that? Because the discovery potential is immense. Some of the most outstanding discovery opportunities include the study and understanding of CP violation in the leptonic sector, which could lead to hints of whether why the universe is made of matter rather than antimatter. Second is study of supernova neutrinos that gives us insights into the origins of neutron stars and black holes. Proton decay that gives insights into unification theory between particles and forces, and perhaps other surprises, new forces, new particles, or new laws of nature. And so you can see that the LBNF and DUNE experiment aspires to answer some of the most profound questions in science and in physics. As I mentioned, in South Dakota, at 1 mile underground, we have been excavating caverns, immense caverns, in order to position up to four huge detectors filled with liquid argon. In the first phase of the LBNF experiment that we're executing currently, there will be 2 detectors installed, as you see here, in the north and south caverns. And you can see here the dimensions of the caverns, and you'll see in a minute the detectors. And the middle is the central utility cavern that's going to house cryogenics, electronics, and so on. And the excavation of the caverns was just completed in February, and that amounted to excavating 800,000 tons of rock for 1 mile underground, bringing it to the surface and then disposing it in the open cut nearby the mine. And recently, on August 15th, we celebrated the completion of the far side excavation there 1 mile underground with representatives from our international community, from DOE, and elected officials from South Dakota. And here, this is the photograph of Tom Zeh, rector of the University of Campinas, who led the delegation of 4 colleagues from Brazil, from UNICAMP, to join the celebration of this amazing milestone. As I mentioned, LBNF Dune is the first international experiment on US soil that DOE is undertaking. And this is actually quite remarkable because this is also the first time that CERN contributes to infrastructure outside Europe. And I will say more in a minute. And in addition, altogether, we want US to be the partner of choice in international science. So it all comes together with LBNF and Dune. And all our partner contributions combined between PIP2 and LBNF and Dune sum up to more than $1 billion. And you can see here the flags of the countries participating to this common enterprise, as well as other DOE national laboratories, including Brookhaven, Argonne, SLAC, and Berkeley Lab. So let's say remarkable among and very important among, significant among in-kind contributions are those towards the far side facility, which include the cryostats of the 2 detectors that are being built now, as well as cryogenic infrastructure. The cryostats are being contributed by CERN, and delivery of the hardware has already started, and the cryogenic infrastructure is being contributed by Brazil and Switzerland. Specifically, UNICAMP proposed contributions to LBNF and Dune cryogenic equipment include liquid argon, circulation systems, and purification systems. And here I want to take a minute and express my deep and profound gratitude both to funding agencies, FAPESP, which is the Sao Paulo funding agency, as well as the federal funding agency of the Ministry for Science and Technology, MCTI, for their generous, timely, and impactful decision to provide in-kind contributions towards LBNF and Dune of substantial magnitude. Now, the Dune collaboration, the Dune experiment now, whereas LBNF is the facility, which is primarily the responsibility of FERMILAB to execute together with our international partners, the Dune experiment is managed by the International Dune Collaboration. This collaboration has 1,400 collaborators, 50% split half and half between US and non-US countries. 35 countries, including CERN, participate, and you can see here noted the Dune collaborators from around the world. And a picture here, this is from the May 2023 Dune meeting at FERMILAB. The most recent one was in January at CERN. No, actually, there was another one, I think, in Santa Fe, most recently. I apologize. And you can see here in red the Latin American countries which are members of the Dune collaboration. And all the partners have gotten together to sign the Dune Multi-Institutional Memorandum of Understanding. And you can see here members who signed in November 2023. And this is effectively all of the members agree to contribute to provide hardware and to Dune experiment. And you can see here Maria Luisa Moretti, who is the vice rector at UNICAMP, at FERMILAB signing the MOU, together with the French, Italian, Swiss, and UK partners. And the DUNE collaboration is responsible for the two FAR detectors, FAR detector 1 based on a horizontal drift and FAR detector 2 vertical drift. And here you see from the flags and the areas the contributions of the various countries from around the world, as well as the US, laboratories. And in particular, CERN has built the two prototypes of both FAR detectors 1 and 2. This is ProtoDune 1 and 2. You see ProtoDune 1 photograph here, and ProtoDune 2 photograph is here. Those are ProtoDune 1 is currently in operation at CERN, and ProtoDune 2 will start operation early next year. And those are part of the CERN neutrino platform. And as I mentioned earlier, it's the first time CERN is investing outside Europe. And you see here ProtoDune 1 and ProtoDune 2 in their location in the neutrino at CERN. And the Latin American participation in DUNE is summarized here. It encompasses countries, comes from Brazil, Chile, Colombia, Mexico, Paraguay, and Peru. It's really delightful to see so many countries and so many institutions participating. And here you see the different topics which span a broad range. And from Brazil, since this conference is being hosted by Brazil, there are 47 Brazilian collaborations from 13 institutions, and you see here the different institutions. And I would like to specifically note the contributions to Arapuca, led by Ana Machado and her team at UNICAMP. Arapuca is a novel photon detection system that effectively is used to detect photons with silicon photosensors. 192 Arapucas have been installed in the short baseline neutrino experiment, about which I'll talk in a minute, here at FERMILAB, and under operation right now, have also been installed, implemented in the ProtoDune single-phase detector at CERN in 2018, and are the baseline for both DUNE FAR detectors 1 and 2. So, and this is award-winning novel light detection technology, and we are very grateful to Ana Ettore and the team for this development. And there is the Photon Detection System Consortium, is the largest among the DUNE consortia, with 49 international institutions, including 17 from Latin America, as you see here on this slide, with 200 active collaborators. So very active and very vibrant collaboration. And before I move on, I wanted to share with you a high-level schedule for the LBNF and DUNE US project. As I mentioned earlier, excavation of the caverns is now complete. Outfitting of the caverns is going to be complete sometime in 2025, where installation of detector components is starting next year. Then building the FAR detectors is going to go on until 2028-29. And as soon as FAR detector 1 is ready, filled with liquid argon and commissioned, science is going to start in 2028. And beam-based science with neutrinos that come from the PIP2 accelerator is going to start in 2031. And then 6 months or so later, the commissioning of the NEAR detector for DUNE is going to take place. And at roughly $3.3 billion from DOE, LBNF and DUNE is the largest domestic project in the DOE Office of Science. Now, as I mentioned earlier, I mentioned about SPND. Let me say that At FERMILAB, we have another long-range neutrino experiment, which is called NOVA, where the neutrinos are sent to Minnesota and detected there. And we have a short baseline neutrino program that comprises 3 detectors. The first closest to the source is the short baseline neutrino detector. The middle one is Microboon, and the farthest out is Icarus. Microboon has completed taking data. Icarus is in operation still, and SBND just came online right before we shut down the complex for the summer. And you can see some pictures of when the detector was being rigged into the cryostat and so on. Here also you can see the collaborators, and I'm very, very pleased and proud to present first SBND neutrino events that we took in early July. And this is the full image, and this is a zoomed in image of the SBND. And as soon as we come back after the shutdown, we're going to resume data taking in from the SBND detector, which is also filled with liquid argon. So in addition to science in its own right, it also is used along with all the other SBN detectors, is used to validate the technology of liquid argon for Dune. Moving on now to give a quick update on Higgs and the energy frontier. FERMILAB is the host lab for the US CMS collaboration, which is the second largest, about half of the total CMS is the US. Here on this frontier, we have 3 major initiatives. One is strong participation in the LHC CMS operations program. Second is we are building components for the HLLHC accelerator upgrade and the CMS detector upgrade. Those are 2 construction projects. And we're just starting accelerator and detector R&D for FCC-EE. And most recently, we completed the first US-built cryo assembly for the LHC upgrade. And this is a picture at FERMILAB before it left. It was shipped to CERN. It arrived at CERN before Christmas of 23, and it has now been tested with very good results that match the results tested here at FERMILAB. The CERN results and FERMILAB results match. And I want to say that this is based on iobium-3 first time applied for accelerator magnets. And it is the result of many years of collaboration between CERN as well as FERMILAB, Brookhaven, and Berkeley labs. Very fruitful collaboration. We're now in the process of starting to test the second cryo assembly, 8 more to go after that. And our high Lumi LHC CMS detector upgrade project achieved CD3 ISAB approval. That means it has entered execution since earlier this year. We have a big program with muons with 2 major initiatives. The first is the muon G-2 experiment. The data taking has been concluded there because the experiment achieved its statistics goal. And last August, a year ago, we published the most precise measurement of the anomalous magnetic moment of the muon. We continue to analyze the data, and we continue to advance the theory initiative, and we expect that sometime next year, the 2 will come together and we'll have the definitive story from this very important experiment. And at the same time, we are building the muon to electron conversion project. That's about more than 90% complete. We expect to start science sometime in 2026. Might be 27 now. I need to check that number, but it's going on full speed ahead. And the plan there is to take a good data set from the mu2e experiment before we shut down the complex for a couple of years in order to connect PIP2 to the rest of the accelerator complex. And then when we come back up again after this long shutdown, we can turn it over so Mutui can resume data taking. And we have a program, a smaller program, but important in what we call dark universe. It is important because here we really apply our laboratory's core capabilities on several elements, including cryogenics, ASICs, high-performance electronics in general, underground, low background noise facilities, and more, to dark matter and cosmic acceleration type of initiatives. Our strategy here is, together with partners, to search for dark matter across a wide mass range, leveraging our facilities and capabilities, particularly in instrumentation, and also to support the advancement of cosmic microwave background experiments while playing key roles in current and upcoming surveys to study cosmic acceleration. Our priorities is to support current operations of Rubin LSST, South Pole Telescope 3G, and Super CDMS. In addition, we are running an experiment called ADMX G2 in Washington for the QCD axion, and we have a number of dark matter new initiatives, including Oscura, that we are pursuing with a goal to down select at some point together with DOE. And here I wanted to say that for the dark energies survey, we are collaborating with countries, with Chile and Brazil. This is the Latin America collaborators are about 65, and the types of science that we do, as you know, of course, the desk camera is installed in Chile, and also operation software and database systems were created by partners in Brazil. Now the a number of institutions from Chile and Brazil participate in this with a large number of collaborators now. And I also wanted to say that CCDs and skipper CCDs for dark matter is an area of a strong collaboration with several Latin American countries. In particular, Latin American groups were early participants of CCDs for dark matter, starting with the DAMIC experiment around 2012. In fact, there was strong support from researchers and students from Mexico, Argentina, and Paraguay to this program, to get this program started even before formal funding came in the US. And now the program has become, the program now has extended to 3 running experiments, as you see here, and 1 planned, Oscura. And the countries involved now include also Brazil, in addition to the other 3, and more than 100 researchers overall participate. And Oscura is a future dark matter new initiative, possible experiment with skipper CCDs. Countries involved include Argentina, Brazil, Mexico, and Paraguay, and contributions span ASIC design, electronics, sensor testing and characterization, calibration and hardware database, DAC design, and so on. And importantly, several of our FERMILAB scientists that you see here, including Juan Estrada, Javier Tiefenberg, and Guillermo Fernandez Moroni, are PhD advisors of students who come from Latin America. Several undergraduate students come to work in our new IRC building where CCD Lab is located, and also remote work on CCD data analysis is ongoing in those countries. So very active collaboration on CCDs for dark matter. And on accelerator science and technology, we have truly world-leading expertise in accelerator and beam physics, SRF, high-power targetry, and high-field magnets. And our vision is to evolve our accelerator complex, also consistent with the P5 recommendation, starting from improvements and campaigns for upgrades of the current accelerator complex in order to support the Dune experiment, and then installing the PIP2 that will replace the front end of the complex, the old 400 MeV room temperature LINAC with the modern 800 MeV SRF LINAC, then executing a SMERT that will allow us to increase the power that's going to produce neutrinos for LBNF from 1.2 to more than 2 megawatts of proton beam power in a cost-effective way and time-efficient way. So we expect this to be implemented in the early 2030s. So that is a fast delivery of Dune, enables fast delivery of Dune science. And then eventually, in the longer term, replacing the existing booster, which dates back since the 70s, with a brand new booster, and that together with PIP2 will form the front end of what could be a muon collider situated at FERMILAB. And all of this, of course, this is our vision for how the complex will evolve over the next 20 or more years. And all of this, of course, will be to deliver groundbreaking science and technology innovation. A couple of words on emerging science and technology capabilities. We have programs in QIS, AI, and microelectronics. I don't have time to go in detail, but and I apologize for that. These are strong programs that both rely on the existing capabilities, also enhance and enable our HEP program, and those developments that we do to support our HEP program are then used to strengthen these emerging technologies for other applications, including societal applications. That is my main message here. Discovery on the Prairie is an integrated vision that we have for our laboratory to expand and modernize the village, to add a new housing facility in the village, the first phase of which could take place starting next year, potentially, with investment from the state of Illinois of $30 million, and with new amenities and so on, and also enhance our STEM programs and add in the long run a technology and innovation park to allow university and industrial partners to work with us hand in hand. We love students. This year we hosted 235 interns in our laboratory, and we love Latin American students in particular, and this is an overview of our program that since 2019 has yielded 20 students from 7 institutions, 3 countries that have completed the PhD program, 20 undergraduates, and over 95% of the students went on to either a postdoctoral position in neutrino research or to graduate school to pursue their PhD in physics. So this is such a great program, and it's win-win for FERMILAB and for the Latin American institutions and for HEP globally, I would say. And here you see some beautiful pictures of our ambassadors to this program. This slide is an overview of Latin American participation, a summary, if you like, in FERMILAB programs according to countries, agreements, and programs. We also, I didn't have time, we're collaborating on software and computing for HEP, including with several groups of JAN4 from Brazil, Argentina, Mexico, and so on. And last but not least, our own strong ambassador to Latin America, Marcela Carena, was one of the first people who led the mandate to create the Latin American Scientific Forum for our research infrastructure. She's a member of the preparatory group for the Latin America Strategy for High Energy Physics, and she has represented FERMILAB as a board member of the Latin American Association for HECAP since its inception in 2021. And in addition, she has a new idea that we have discussed also with Rogerio and other colleagues, which is also extremely promising, which we call mobility initiative between FERMILAB and the Latin American Association for High Energy Physics, which is to identify areas of mutual interest, develop proposals, have a joint review committee to review those proposals, and then those selected would be funded from FERMILAB at some low level, or other funding would be funded by FERMILAB, the successful proposals, and would imply that we invite those scientists and students to come to FERMILAB, or FERMILAB scientists go to Latin American countries for a certain period of time. And that would enable the mobility among our respective institutions. So we're taking it very seriously. We're thinking about it. The investment is relatively modest, so we should be able, but the impact is going to be huge. So I love this initiative that Marcela suggested, and we're going to do everything we can to realize it. And I will wrap up with some beautiful photos from, for example, the FAPESP representative visit to FERMILAB back in April, our visit with DOE, Gina, Abit, and several from FERMILAB to Brazil in May, MCTI here, and then and FAPESP and so on. And last year we visited ACAER and UNICAMP, and this is the delegation from Sao Paulo, including Pacheco from FAPESP, and 3 members of UNICAMP, including the rector, vice rector, and Pascual, who came on August 15th to celebrate the excavation completion. And other pictures here from visits, and then from a strong partnership from other Latin American countries, as you see here from Chile and Venezuela and Argentina and more. And so I conclude here, and thank you so very much, first of all, for your partnership, and second, for listening.
Thank you.
We have an opening discussion after.
Yes. No, this was so comprehensive. It was amazing.
Right.
We really want to thank FERMILAB for all these opportunities and partnership with us.
Yeah.
I really want to thank my colleagues, Marcela and Juan, and Marcela helped me, who helped to put material together.
Daniel, Flavio.
Daniel, Flavio.
Who are not many Latin Americans in Argentina. I mean, Argentina is Minerva, I'm sure. I'm sorry if I'm missing people like, well, Javier and Guillermo, of course. I would just like to say that there are many very devoted scientists from Latin America in FERMILAB, and I think we all are so excited about bringing this collaboration between FERMILAB and Latin America a step further in this new era. So we thank Lia for supporting our initiatives and efforts.
Yeah. Thank you, Marcela. Carla has a question.
Yes, also, hello. I also would like to add that thanks to this partnership in Brazil, we have an experiment for neutrino detector that is taking data continuously in Angra 2, and this also was possible thanks to the work from Javier Tiefenberg and Juan Estrada and this participation, and I wanted to mention that because this creates a unique possibility to my colleagues and to me and to the Argentinian colleagues to develop the skipper CCDs, and now we install one MCM that is the new concept from Sensor for Oscura. We are testing that, so also this shows the partnership with FERMILAB. And then I would like to make a wish that is, I hope that in the near future, the situation to have foreign people in FERMILAB will be better, and that we can recover part of the ambient that we have several years ago, before pandemic, I would say, where I have the opportunity to spend a year and it was very peaceful. And I hope that the new generation of students would be able to also to profit of that. Thank you for your talk. It was very nice.
Thank you. I would like to follow up with you offline, Carla, about the situation at FERMILAB you're referring to.
Yes, that's good. I was part of the access committee, so we discussed several times. But of course, I can continue helping from the South American side.
Thank you. I believe we have significantly improved site access while trying to stay compliant. We're not done yet, but if there is anything I can do to further help, please let me know.
Thank you.
Absolutely, thank you.
Thanks again.
I withdraw. It was related. It was related. I withdraw.
Okay. This was already answered.
Yes.
So thanks a lot again to Will.
Thank you. Thank you so much. Bye-bye. I wish you a very productive meeting, symposium, and I regret not being there. Thanks a lot. Bye.
Thank you, Lia.
Thank you, Marcela.
You want to say something?
I think it's here.
So we are doing a Lia, are you there?
No. That's okay.
So only because I want to say that I'm impossible to stay two places at the same time. But anyway.
But pop is together, so.
Yes. Yeah.
Yes, actually, we're invited to the welcome reception. Thank you, Anna.
So where is it and what time?
I think